Hello guys, welcome to lesson 2 of Mathematics for Natural Science course. I hope you understand the concept we discussed in video lesson 1. So before we proceed to the second lesson, just let's revise the basic points we discussed in lesson 1. So the points we have seen in lesson 1, the first one is the definition of a preposition or a statement. Remember, any sentence which can be said true or false but not both at the same time, we call it what? Preposition or statement. And to represent preposition, we use small letters. The usual letters are what? P, Q, R, S. And also the 5 logical connectives with their rules. We have seen the name, the symbol, and the meaning of each logical connectives with the corresponding rules. So the 5 connectives are what? Negation, conjunction, disjunction, implication, and by implication. So hoping you grasp the rules of these 5 logical connectives, we will proceed to the second lesson. Plus, we have seen how we can construct truth table for compound preposition. So by now, you should know how to construct truth table for a compound preposition. Now, having this in mind, in lesson 2, we will start from the point of converse, inverse, and contrapositive of the conditional statement. Now, P implies Q. The meaning of implication is what? If the. So P implies Q is equivalent to if P then Q. That means when you convert symbolic form to verbal statement for implication, in lesson 1, we discussed that we use if then conditional statement for implication. Now for this conditional statement, if P then Q, we have what we call converse, inverse, and contrapositive. So let's start with the converse. Now Q implies P, we call it the converse of P implies Q. A statement obtained by interchanging the hypothesis and the conclusion. Q implies P, we call it the converse of P implies Q. And again, negation P implies negation Q, we call it the inverse of the conditional statement P implies Q. The negation of the hypothesis implies the negation of the conclusion. This is the inverse of P implies Q, and negation Q implies negation P is the contrapositive of P implies Q. So given a conditional statement, we can find the converse, inverse, and contrapositive. The contrapositive, the negation of the Q implies the negation of what? P. This we call it contrapositive. Now in lesson 2, we will see this contrapositive, negation Q implies negation P, is equivalent to P implies Q. Equivalent means if P implies Q is true, negation Q implies negation P is also true. If P implies Q is false, negation Q implies negation P is also what? False. They are equivalent. Even in advanced mathematics, we have what we call proof by contrapositive. The proof conditional statement of the form if P then Q, sometimes we prove their contrapositive. Because if the contrapositive is true, then the conditional statement will also be what? True. So this is important point you need to remember. So let's take example. Let P stands for Ethiopia is in Europe, a preposition, and Q stands for a preposition, 3 is a prime number. So write the converse, inverse, and contrapositive of P implies Q in acceptable English form. So first, let's write P implies Q in terms of verbal statement. P implies Q means if P, then Q. If P means if Ethiopia is in Europe, then Q, 3 is a prime number. So if Ethiopia is in Europe, then 3 is a prime number is the verbal statement of P implies Q. This is symbolic form. This is what? Verbal statement. So for this conditional statement, we are going to find the converse, inverse, and contrapositive. Now the converse, Q implies P. If Q, then P. If Q means if 3 is a prime number, then P, it appears in Europe. So if 3 is a prime number, then it appears in Europe is the converse of P implies Q. Now for the inverse, yes, we take the negation of P and the negation of Q. The negation of P is what? Ethiopia is in Europe. The negation is what? Ethiopia is not in Europe, because the meaning of negation is what? Not. So if P stands for Ethiopia is in Europe, then negation of P is Ethiopia is not in Europe. So if negation P means if Ethiopia is not Europe, then negation of Q, 3 is not a prime number. So this is the inverse of the conditional statement P implies Q. The third, contrapositive, if negation Q, then negation P. If negation Q means if 3 is not prime number, then negation P, Ethiopia is not in Europe. By the way, when we find converse, inverse, and contrapositive, just don't bother about the meaning of the statement. Just follow the form. Now in logic, the contrapositive, if 3 is not a prime number, then Ethiopia is not in Europe, is equivalent to if Ethiopia is in Europe, then 3 is a prime number. They are equivalent. We will see. These two are equivalent. They will have the same truth value for all logical possibilities. So for you as an exercise, 1 up to 5, find converse, inverse, and contrapositive of each statement. Just try to find the converse, inverse, and contrapositive. So once we know the converse, inverse, and contrapositive for conditional statement, the other point is how we can check whether a compound preposition is a tautology or a contradiction. Our compound preposition, we call it tautology if it is true for all logical possibilities. So by constructing a truth table, if the compound preposition is true for all logical possibilities, then we call it tautology. In general, a compound preposition is a tautology if only for every assignment of truth values to the constituent preposition occurring in it, the compound preposition is true. Meaning, for all logical possibilities, if you get true, then the compound preposition is tautology. Let's take an example. It says, show that the compound preposition negation Q and P implies P or Q is what? A tautology. By now, you know how to construct truth table, so we are going to construct truth table. If you get all true, then it is tautology. If one of the 4 logical possibilities is false, then it is not tautology. So let's construct truth table. This compound preposition is composed of what? 2 components, PQ. So for 2, we have 4 possibilities. How many connectors? Negation, conjunction, implication, disjunction. So we have 4 logical connectors. So for each logical connector, we'll have 1 column. So let's start with the negation of Q. Opposite of the second column, false, true, false, false. Just opposite of the second column. Next, let's construct for negation Q and P. So in the first column, we apply the rule of conjunction. So the second column is for conjunction. So negation Q and P. So we combine first column with third column based on what? Conjunction. For conjunction, when both are true, it is true, otherwise false. When both are true, P and negation Q, when both are true, it is true, otherwise it is what? False. True and false is false. False and false is false. False and true is what? False. Only true and true is what? True. So for the fourth column, we apply the rule of what? Conjunction. And for the fibs, let's take P or Q. The rule of disjunction. If both are false, it is false, otherwise it is true. PQ. PQ both false. In the false row, false or false is false, otherwise it is what? True. And finally, we combine negation Q and P and P or Q by using what? Implication. So from the fourth column to what? Fifth column based on implication. From left to right. The order is important. For implication, the order is important. So false implies true, it is true. True implies true, it is true. False implies true, true. False implies false, it is what? True. So we don't have a case where the hypothesis is true and the conclusion is false. We don't have such case. Because of that, all are what? True. So if all are true, then the compound preposition is what? Tautology. So in general, whether you have 4 logical possibilities or 8 or 16, if it is true for all logical possibilities, the compound preposition, we call it what? Tautology. Now, in case all are false, for all logical possibilities, we call the compound preposition contradiction. So by constructing truth table, we can show P and Q and negation of P or Q is what? A contradiction. Again, this is composed of what? 2 component preposition PQ. For 2, we have 4 possibilities. So we need P and Q. Conjunction, when both are true, it is true, otherwise it is false. Before we find negation of P or Q, let's find the truth value of P or Q inside the bracket. P or Q, when both are false, false or false, it is false, otherwise it is true. So the negation of P or Q, the opposite of the first column, the opposite. And finally, P and Q, the third column, with what? The negation of P or Q, the fifth column, the third and the fifth, based on what? Conjunction. Now when we use conjunction, when both are true, it is true, otherwise it is false. So true and false, it is false. False and false, false. False and false, false. False and true is what? False. We don't have a case where both are true. P and Q and negation of P or Q, we don't have both true. So we get what? All false. So the compound preposition is what? A contradiction. So in case the compound preposition is not, it is not tautology or at the same time not contradiction, we call it a contingency. So a preposition that is neither a tautology nor a contradiction, we call it what? A contingency. Neither of the two, we call it contingency. And the other important definition we need in prepositional logic is the definition of equivalence. So 2 prepositions involving the same component preposition are said to be equivalent if and only if they have the same truth value for all logical possibilities. In case you have 4 possibilities, for all, we must have what? The same truth value. In case we have 8 logical possibilities, for 8 logical possibilities, we must have the same truth value. So in general, 2 prepositions involving the same component preposition are said to be equivalent if only they have the same truth value for all logical possibilities, and this is the symbol for equivalence. Now let's take example. Negation of P if only if Q is equivalent to negation P if only if Q. So to show these 2 are equivalent, we are supposed to show they have the same truth value for all logical possibilities. So for the time being, we use truth table. So we construct truth table for negation of P if only if Q, truth table for negation P if only if Q. So on their truth table, we can check whether they have the same truth value for all logical possibilities or not. So I'm going to use one table for both. So to construct a truth table, the compound preposition is composed of two PQ. So the four possibilities as usual. So we need negation of P. Let's find negation of P. Opposite of the first column, false, false, true, true, the opposite of the first column. Then we need P if only if Q. In case of by implication, when both have the same truth value, it will be true. Otherwise, it is what? False. That is the rule of by implication. So once you have P if only if Q, you can take the negation of P if only if Q. That is the opposite of the fourth column, the opposite of the fourth column, and negation P if only if Q, negation P if only if what? Q. So the third and the second column based on by implication. We combine the second and the third column based on by. In case of by implication, when both have the same truth value, it will be true. When both have the same truth value, it is true. Otherwise, it is what? False. So at the end, for negation of P if only if Q, we get what? False, true, true, false. At the same time, for negation P if only if Q, we get what? The same thing. False, true, true, false. So these two compound prepositions have the same truth value for all logical possibilities. So from the definition, we can conclude negation of P if only if Q is equivalent to negation of P if only if Q. So based on truth table, we can show the equivalency of a compound preposition. Now for the second, we construct truth table for each compound preposition, but here I'm going to construct one table for the three compound preposition because all the three are based on PQ. So for PQ, four possibilities. So to construct the truth table for each compound preposition, we need the negation of P, which is the opposite of the first column, opposite, false, false, true, true. We need negation of what? Q, the opposite of the second column, false, true, false, true. Then negation Q implies negation P. From negation Q is the hypothesis to negation P. So the order is important. We imply from the fourth column to the third column. False implies false is true. True implies false is false. False implies true is true. True implies true is what? The order is important. If you reverse the order, you will get different results. So it says what? Negation Q implies negation P. So you need to imply from the fourth column to the third column. False implies false, true. True implies false, false. False implies true, true. True implies true, true. So for negation Q implies negation P, we get what? True, false, true, true. Again, for negation P or Q, we combine negation P, third column with second column based on what? Disjunction. In case of disjunction, when both are false, it is false. Otherwise, it is what? True. Both are false in the second row. False or false. False. True or false. True. True or true. True. False or true. True. So for negation P or Q, we get what? True, false, true, true, which is similar to negation Q implies negation P. Again, P implies Q, remember? For implication, true implies false, becomes false, otherwise it is what? True. So as you can see from the table, we get what? The same truth value for the three compound preposition. So they are what? Equivalent. Negation Q implies negation P is equivalent to negation P or Q. This is also again equivalent to P implies Q. When we talk about the inverse, converse, and contrapositive, I told you that conditional statement is equivalent to what? The contrapositive. This is the contrapositive. So conditional statement P implies Q is equivalent to what? Negation Q implies negation. So these two are equivalent in logic. Again, negation P or Q is also equivalent to the conditional statement. Now, having this in mind, you can easily show these given compound prepositions are equivalent respectively. Already the second, we proved. But for the remaining, you can show they are what? Equivalent. So the last point in the second lesson of Mathematics for Natural Science is the property of each prepositional connectives. Now for the preposition PQR, we have the property of negation. Negation of negation P is P. Negation of negation P is equivalent to P. We have commutative property. Conjunction is commutative. Disjunction is commutative. By implication is also what? Commutative. P if only if Q is equivalent to Q if only if P. If you interchange the PQ, you will get the same truth value. They are equivalent. But in case of implication, P implies Q is not equivalent to Q implies P. Even Q implies P is the converse of what? P implies Q. They are not equivalent. So only conjunction, disjunction, and by implications are what? Commutative. Now when it comes to associative property, conjunction, disjunction, and by implication, they are what? Associative. But implication is not associative. They will not have the same truth value for all logical possibilities. Now for distributive property, conjunction is distributive over disjunction. Just the way we say multiplication is distributive over addition, in logic, conjunction is distributive over disjunction, meaning P and Q or R is equivalent to P and Q or P and R. That means we distribute conjunction over disjunction. Similarly, you can distribute disjunction over conjunction. Even disjunction is distributive over implication. P or Q or R is equivalent to P or Q implies P or R. You can construct truth table. You will have 8 possibilities. These two compound prepositions will have the same truth value for the 8 logical possibilities. You can check it. Now, the other important property is the De Morgan's law. Negation of P and DQ, the De Morgan's law of conjunction. Negation of P and DQ is equivalent to negation P or negation Q. So when you distribute negation of P, conjunction becomes disjunction, negation of Q. And again, when we distribute negation, disjunction becomes what? Conjunction. Negation of P and negation of Q. This we call it the De Morgan's law. Just based on truth table, you can show they have the same truth value for the 4 logical possibilities. Now, loss of contrapositive, already we proved. P implies Q is equivalent to what? Negation Q implies negation P. This is the contrapositive of P implies Q. They are what? Equivalent. We call it loss of contrapositive. Again, negation P implies negation Q. If you take the contrapositive of this, you will get Q implies P. These two are equivalent. So from now on, by loss of contrapositive, you can say P implies Q is equivalent to negation Q implies negation P. Or Q implies P is equivalent to negation Q implies negation Q. The last independent law, P is equivalent to P or P. It is simple. For a single preposition P, you have what? 2 options. It can be true or it can be what? False. So in case P is false, false or false is what? False. That is equivalent to P. If P is true, true or true is what? True. So P is equivalent to P or P. Again, P is equivalent to P and P. Because if P is true, true and true is true. If P is false, false and false is what? False. So P is equivalent to what? P and P. So try to read again and again until you have the idea of the properties of the prepositional connectives. Finally, Try to do these exercises 1 up to 10. Determine whether each of the given compound prepositions are tautology, contradiction, or what? Neither. Neither means contingency. And also for 11 up to 15, check whether the given compound prepositions are equivalent or not equivalent. Based on truth table, try to check whether they are equivalent or not equivalent. So this is all about lesson 2. As usual, just keep practice and understand all the concepts we discussed so far, even in video lesson 1 and also in video lesson 2. After you revise lesson 1 and lesson 2, you can start lesson 3. Thank you.